This is our agenda for today, 1 hour 30 minutes, which we are going to cover all these topics. That is geographic data import and export, 2D and 3D map displays, terrain and elevation analysis, geometric, geodesy and map projections, data representation and transformation. So all these topics we are going to cover. So let me tell you that this is very vast. Actually it depends on your application area. Again, that in mapping, what is your application area, based on that you can be expert. So in 1 hour 30 minutes we have to cover all these things. So I will try to give at least with examples, overview, and with examples everything I will cover it. Okay. First of all, we'll start from the key features which are available in mapping toolbox. I will take just 2 minutes for that. So mapping toolbox in MATLAB. First of all, there are more than 100 toolboxes available in MATLAB. One of them is that is mapping toolbox. Mapping toolbox is used to analyze and visualize geographical information in MATLAB. So these are some key features like export and import, like vector data and raster data. We will discuss later what is vector data and raster data as well after these key features. We can customize a raster map, or we can retrieve raster data from web map services also. For example, if you know the link of ISRO, where they log data, geographical images or raster data, you can retrieve that kind of data in MATLAB. Fine. So the web map server works basically with internet to retrieve data. Further, web map display with dynamic base maps for OpenStreet, and already there is a inbuilt street map and different kind of maps. If I am working on live data, we can use this kind of live maps to display our data on it. Okay. 2D and 3D map display. We can design 2D maps as well as 3D maps also. We will discuss all these things. Customization, and if you have to interact with MATLAB, then we can do interaction also. I will show you one example how to interact with map also. And digital terrain and elevation model analysis functions are available in mapping toolbox. So we can do analysis on digital terrain also, and we can do analysis on elevation models as well. Apart from that, if you have to use a geodesy function, if you have to find out the area or intersection points of two circles or something like that, we can use geodesy functions also for that. It includes 2D and 3D coordinate transformations also. And in mapping toolbox, there are more than 65 projections. We will discuss that what kind of projections are available and how we can project our data in a different kind of projection. Okay, first of all, we'll start from the types of geodata which are available in mapping toolbox. So first is that is a vector geodata. Vector geodata, basically the data are in a sequence in a pair, like latitude, longitude, or it can be in the form of xy, projected xy. On each and every point there will be a distance value or lat long value, that is a projected xy value, or it can be in the form of lat and long. That is a vector geodata. So these images which you see, like it can be edges in vector data, or it can be a polygon, like which you see that India map, or it can be points also. So we'll see that how to transform line to point to line and line to polygons also. So these are the vector geodata which we can access in MATLAB. Second is raster data. Raster data, again, there are two types. Basically the data which we have in a raster data, that is data in the form of matrix. So two inputs will be in raster data. One is matrix of images or matrix of topographic data. So or and another will be a reference. A reference can be projected or unprojected. Projected, if I am talking, then it will be in the form of a lat long. Unprojected means you may say it will be in the form of distance. So these are topographic data, and these are the images. So two types of raster data are there. So this which you see, the first is that is called digital elevation data. So you can see in this image there are elevations as well, in both figures elevations are there, up and down like this, right? So it is also called a topographical map. So this is a raster data. This data again I am saying it will be in the form of matrix, and we will have a one reference to visualize that data. Two things we require to visualize our data. Second is images type, remotely sense images data. It will be something like that. It can be a GPS data as well. So this data will be in the form of grid, or it can be in the form of images. So it can be organized as a row and columns, and each row and column represent a pixel value plus geographical information of that images. That is a raster data which we are giving. Now next, hope that data types are clear. Now import and export data in MATLAB. This is about the geographical data export and import. So first, if I have raster data, then how we are going to import in MATLAB, or how we are going to export in MATLAB. These are the standards files. If you have a geospatial raster data file, then you can use rate geo raster data. This functions was introduced in MATLAB 2020A. Some more informations about raster data you can see here, that what kind of data you can export and import in MATLAB. You can have a world file data, or you can have a IM read. So these are the functions inbuilt in MATLAB which you can use to import in MATLAB. If you want that what variables are available in this kind of data, just get information functions are there, like geo raster information, geo tif file. If you have that, this is the function that which we can use to find out the information that what variables we available. Sometimes it is required to identify that what kind of variables are there, what kind of data are there, because we don't require to import whole data in software. So that's why to write data, this kind of things we use write again geo tif write, world file tif write, im write. So we'll discuss about these things later. Okay, so these are the standard files that which you can import and export in MATLAB. Let me show you one example. Let's say I have one JPG image. So this is a raster data actually. So to read it as a image, we give a command im read here. Then we require the world file name. What is the world file name of it? So there is a inbuilt function in MATLAB, get world file name. After getting the file name, then we read that data as a world file read. This is the world file name, and here you see option is geographic. Geographic, if I give the answer, then it will be in the form of lat and long, or instead of geographic we can give a planar as well. So depends on you want to import data as a geographic or as a planar data. Planar data will be like a local Cartesian form. Okay, so if I run this function in MATLAB, so here you can see this is the image. This is a latitude which you see, and the on x-axis is longitude, and r, this is a reference. Based on this reference, that image is plotted using the geo show. So first thing that here that I use the geo show. Whenever you have data as a latitude and longitude, you are going to use the geo show. Else, if you have unprojected data, then you are going to use the map show for that. So here is the, you can see here the reference are as a lat long. This is the limit of latitude, limit of longitude. What is the raster size, means minimum and maximum value, and from where it will start from north side, and from where row will start. All informations are given there in that image. Fine. So same, this is a raster data type read and write. Another is that is vector data. Again, these are standard file formats. You can have data in a shape file, or you can have data in the GPS format also. Okay, so this is the way how we are going to read this data. And here again you can see this is the PDF from MATLAB. So if I click on any functions, like if I have GPS type of data, I use GPS read. If I have Hello.
Yes. Yeah. I think whatever you are speaking, the light show is taken by one slide.
Haha.
So once you extend, then it is appearing on the screen.
So is slide
So
is
we
a
are
is slide is slow,
slide is
sir.
one. Yeah, one slide delay, almost one slide delay. Whatever you are speaking after you complete it, then it's coming on display.
Oh, maybe sir, I don't know. Maybe internet speed is slow or what, but I am moving my slides. Right now, sir, can you see this PDF?
Now we are seeing this video.
I have to be more slow, sir, I think, because it is taking long time to move from slide.
So once you press the next button or change button, just see whether it display, then you can.
Okay, I will ask that actually first of all because
Yeah,
from this side, sir, actually I don't know. So okay, I was explaining these are vector. If you have vector data can be in the form of shape file or it can be form of GPS file. That is a standard file format of vector data. Again, if I have data in shape file, maybe I don't require to read all information from shape read. That's why we give the command save info to find out what kind of variables are there, and based on that we can extract that specific variables by using shape read command. Fine. Okay. Sir, this is visible now. I did the next on PPT. Hello.
yes, it is
Okay,
visible.
okay, fine. So let's say I have a data in a GPS form. Again, here you see what we are doing it. This is a we are reading data. Again, A will be a matrix of this image, and R will be a reference of that. And when we got this matrix, when we got a R, here we are using map show. See, remember here we are using map show because this is the image of that map show. This is not a projected data. If it was projected, then we had a lat long value as well. So depends on you what kind of data we have. And further, we will discuss that if I have unprojected data, then how to convert in a projected reference also as well. So I am going to plot this. So simply GPX read for the GPS data, and then read that raster data, and using the map show you can plot it. So it will look like this. So in this case, if when I did a map show, here you can see the distance. It is showing in the form of distance as a kilometer, not on a lat long form. X-axis is distance and y-axis is also distance. The form of x-y coordinate actually it is showing you in this case. Next, about plots, 2D and 3D plots, map plots. How do we display it? Sir, it is visible this slide, 2D and 3D map display.
Yeah.
Okay, sir. Okay, fine. Okay. Okay. So before to do a 2D and 3D map displays, means plotting the map as a 2D or 3D, we require to set the axis first of all. Here projection comes. That what kind of map projections do you want first of all? So we use to project for the projection we use AXESM, axis M. We use this that what kind of projections we are like if I want a Mylar projection, I will write AXESM Mylar. Later in the last slide we will discuss that what kind of more projections do we have. If I have to do a sinusoidal kind of projection, that say TAM, or you can write XM, this axis M sinusoid, so it will be projected in this form. Or if you are working on map what in I mean if you are working on country projection like world map, if you are working on the world map like I want projection of South America, I will type world map space South America, I will get the projection of South America. Same if I want a projection of India, I will type world map space India and I will get the projection of India. Let me show you some examples how to project. This is the first thing that we have to do before plotting as a 2D or 3D. Okay. So okay, this is live script is visible, sir. This is script file.
Yeah.
Yes.
Okay, this is a live script. In live script, we can visualize our numeric data and figure in the same figure window. Earlier, there was only a script file only from MATLAB 2016 earlier. Now we have a live script. So, like how we are going to project this? Access M. Here, this is a property name that map projection and what kind of projection do we want. And if I want to on the frame, then frame on. So, property name and property value, property name and property value. If you want to know more that what kind of options you can set using this, just right click and go in the help. And here you will get the more information that what kind of more properties you can provide it here. So if I click on the name value pair, so this is showing you the name value pair, map projections, then map, lat limit, long limit. So you can give the limits as well. So now if I run this, I will get the Miller projection here, like this. Further, if I want to, what is the line width? So get GCA, get current axis, and what is the line width? Then whatever line width is there, I am going to set the line width as a 4. So set M. Get M means get the information of axis, set to set something there, like this. See now it is more thicker than before. Before it was 2 width, now it is 4, like this. So same you can like here we are using Robinson. So get current axis, line width again 3 we are doing, grid is on. So you can see grid also and what kind of projections I want. So this is very important before going for a 2D or 3D plot, that what kind of projections do you want first of all. So if I give this command, get current get M, get current axis, so all informations will be here, that what informations do you have in that case, like this. So this is the way that how you are going to set the projection for your data. Okay. So I am going to close this. Another is that you can do geographical data plotting and non-geographical data as well. Use geographic and non-geographic objects. So like this also you can project it. Axis, what kind of projection do you want? Frame on, grid M, grid also on. So a simple Cartesian plot which you use. Simple Cartesian plot which you use in MATLAB, we use axis, not M. If I have to on the frame, we use just frame, or if I have to on the grid, I use just a grid. So in MATLAB, in mapping toolbox, we use M in the last, like axis M, frame M, grid M, M label, P label, meridian label, and this is the parallel label will be also on, and grid off. If I run this, my projection will show like this. So you can see meridian and parallel both are on, and grid is also here on. And here we see, this is very important. This text which you command, you see, this is for the simple local Cartesian. If I write the text on my geographical reference, then we use text M, latitude value and longitude value. And in this case, we require a x-axis and y-axis, like this. If I run this, so both you can use geographical or non-geographical also. So you see here, the first one is geographical and second one is non-geographical. So here you can see both axes are showing local and geographical. Like this, you can do a projections of your map. Now, if I am working on world map, let's say I want just wait a minute. Okay. About world map, it will work like this. Let's say that I want to plot coastline. So for my first command will be, in this case, I will just type world map world. So what it will do, that it will open a coordinate of world maps like this. I am using a default projection in this case. Okay. After doing this, we have shapefile here, land areas. We have to plot here land areas. So you can see I am using GeoShow. It means it will be performed as a lat and longitude value. Means it is a projected value. Then land areas dot shapefile, and what will be a color of this. So this is a red intensity value, green intensity value, and blue intensity value. If I give these colors, it will look like this, that land area. Okay. So now to GeoShow directly, even we don't have to read the shapefile, directly GeoShow we can use, and this is the shapefile and it will be plotted there. So first projection and then plot. So it is taking a little time, because so like this you can plot it. Later we will discuss, there is one example I am going to take. There we will do pre-processing also if their data are missing, and how to visualize that data interactively on map. Okay, this example I will show you in last. So like this we can do a 2D map plotting. Okay, this was about 2D plot if you have polygon kind of plots, or you may say if you have a raster data, this kind of things, or if you have a raster data as a images, already we discussed. Just read Georaster. One thing I want to show you, that what kind of file formats are supported in a raster data. Read Georaster. So if you want to know any information about function, just give a command doc and the function name here. So if I click on this file name, here if I go more below here, so these are the file formats which are supported as a raster data. So any kind of data if you have as a raster data of this file extension, you can import and export in MATLAB. Okay. So to plot a raster data, just read Georaster and your file name, then map show. This is Booston, again this will be a matrix, and R is the reference for this, and X is image, and whatever title if you want, it will be shown there. Okay. So this was about the 2D map display. How to display it. Now 3D, if you want to do a live 3D map display, it is very simple. What I want to do, to display a globe map, we use Geo globe command, and UI figure means user interface figure. On this I am plotting Geo globe, and further what we are doing it here, to plot a 3D coastline data. Here in coastline data we have a latitude and longitude values. So Geo globe, it will look like this, and on same globe we are plotting it latitude and longitude data. So if I run this function, just wait a minute. Okay, so what it will do, first it will load this latitude and longitude, and further it will open a user interface figure. It will plot a globe on that, and what data we are going to plot it. That is latitude and coastline longitude data. So, but in this case, you require an internet connection. We will discuss how to do a 3D plot without internet as well. So here, live map will be opened up globe in this case. So like this. So this is a globe, and you can see these coastlines are plotted here. See everywhere that coastline which I had as a lat and long form, and it is plotted on this globe. further I want to do some kind of some specific lat long. If I have to plot it like this, I have two values lat and two values of longitude. It is the interpolation. I want to increase that lat and long value. We use m. We will discuss about it later. So some specific lat long value also you can plot it as a line. You can see this is visible here like this. Okay, one thing more here. You can plot it as a without maps, without internet also. So in this case, if you have to plot a globe without internet, first of all we have to set axis projection what kind of I want, and clipping and grid what will be a grid and what will be a color, that value I am going to give it. So it will look like this. Now what we are going, we are loading that again post line data, and in this case this is a 3D plot. We are using plot 3m. In the basic Cartesian we use plot 3, here plot 3m, and what we are plotting, latitude, longitude, and this will be a, this is the value 0.01, that will be a thickness of it, and color will be as a black. So if I run this, so here is the globe plot. So why I am getting this as a globe, because I set my axis here as a globe projection. So now it looks like a globe plot. And further how to convert georeference cells in MATLAB. This is very important. First of all, if I have to create a raster data, let's say, so this is the raster data which we are creating it. Minimum value is 120, maximum value is 360. This is the raster, this is the matrix. Now how to create a georeference cells. This is a latitude minimum maximum limit. This is a longitude minimum and maximum limit. Okay. So what it is showing you, this will be plotted on the whole globe. After doing this, and if I run this, this is the color, that what kind of color I want, and geo show. Because geo show again we are using because reference is as a lat long. So this is a projected value. So your globe will look like this. So this is a 2D globe, how we, I mean without internet, sorry, this is a 3D globe without internet. You can plot it. Define the axis, projection, then you will have a raster data, or if or you can have a vector data also. If you have a vector data, then it will look like this. If you have a raster data, then it will look like this. So if it is a projected data in the lat long form, you will use geo show, else you are going to use the map show for that. Fine. So this was about the 3D plot, how we can do a 3D plot in using mapping toolbox. Now about there is one more very important plot that is called as a thematic maps. Okay, we did a 2D plot, 3D plot, now thematic maps. Thematic maps we use to plot stem, we use plot as a scatter, we use contour plot, we use surface plot in georeferenced data. That is a thematic map. Here you see this this is South Asia, and here this black lines which you see, that is a contour, and remaining which you see blue, and this is the surface kind of plots. Or it can be a stem plots. Let's say that on any specific area you want to find out what is the value, where the value is maximum and minimum. So based on this stick you can identify it. Same this is again surface plot of it. So let me show you some examples of thematic plot, and before that, what kind of thematic maps you can plot it. So here is the, like if you have to do contour plot, we use contour m. If I have a 3D contour, if I have to do, I will use contour 3m. Same projected field contour, contour fm. So it will look like a surface plus contour both. So these are the functions which are available, like steam plot and steam 3m. QVR plot, project 2D QVR plot, QVRM. So instead of QVR or instead of contour, always we add the M to do this. This is the thematic plots here. And let me show you some examples of thematic plots. We will discuss how to convert this georeference. Again, what we are going to do, we are loading the topo data where we have latitude, longitude and matrix as well. Now we are creating a georeference of it. Georeference cells we use it, latitude limits, minimum and maximum, and this limit. If I load this, if I run this one, I will get this topo lat limit and topo long limit as well here on my x-axis. Here it is available. So this data already we have, that what will be a minimum and maximum value of latitude and longitude. Okay. So now lat limit, long limit, and what we are doing it, we are not going to plot all data which I have in topo, whole world. We are going to plot only South Asia. So you can use geocrop from topo data, and this is a South Asia limit, latitude and longitude limit for the South Asia only. We cropped it. Z we got as a matrix, R will be a reference of it. So Z is matrix, that is raster data, and R is the reference for that. Okay. Now to display this image, first of all we have to set that what kind of axis do you want and what will be a limit of axis, then contour 3M for the contour plot. If I run this, we will get a contour plot of this. So this is a contour plot right now, just of South Asia. And here axis, you see that we set it projection as a Lambert STD. So that's why it looks like this. Further, we are going to plot the topo data using the GeoShow on the same figure. Now you see it will looks like this. So this is a example of thematic plots. So depends on you that what kind of thematic plots do you want to do, you can do it. So there are multiple thematic plots you can do it. Already we discussed like stem plot, contour plot, surface plot, different kind of thematic plot. And the good thing is that after doing the thematic plot, it will give me a color annotation as well. I can identify here from the color, if it is blue then their values are low. If I go up then their values are very high. Let's say if I have to do analysis of ozone layers, we'll discuss one graph I have on the ozone also, aerosol data I have, where layers, where ozone values are maximum, where it is low, like this. Based on the color we can identify as well. Next is data analysis on georeference data. So first of all, what kind of analysis we can do using vector data, what kind of analysis we can do using raster data, what kind of analysis we can do further using both vector and raster data, and what kind of analysis we can do in terrain and elevation data analysis. So in vector data, what kind of analysis we can do? We can do some kind of convergence, like from point to line or line to polygon, or plotting kind of thing. This is the vector data analysis which we can do in MATLAB. Like interpolation, I will show you some examples how to interpolate. If you have missing data, then how you are going to find out that missing data. Okay. So interpolation is there, buffering, if you have to do a polygon. So these are the functions for working on vector analysis. Second is here, that is raster data. In raster data, what we can do maximum, again here also we can do interpolations kind of things, but based on the raster data. So if I click on this, these are the functions which are available, which we can do. What we can do, reference object and latitude, longitude grids. We can create references, like before we were doing georeferences or unprojected references. Or further you can analyze and manipulate data, like I told, interpolation and that kind of things. Also you can do based on the raster data and the vector data. Both are similar, but the data are different. Conversion between vector and raster data, we are going to see examples. Let's say you have a vector data, you have to convert in a raster data, and vice versa. If you have a raster data, then you are how to convert in a vector data. We are going to see these examples. And the last one examples we will see on that terrain and elevation data analysis also. How we can do analysis on terrain, what kind of analysis you can do. Here in terrain and elevation, what you can do, you can find out the gradient, or you have to make a line of sight analysis, or you have to view shades at some points, shading kind of things. So first of all, let me show you some examples that what kind of analysis we can do in that thing. Okay, so first of all, let me show you how to interpolate this data. In this case, you see, let's say I have a latitude value 1, 2, 4, 5, longitude value 7 and 9, 11. So you can see 3 is missing, right? And here 10 is missing. So we use interpm. If I give this command, it will interpolate all this data, and we will get the output. Now you see that 3 was missing. Now we got that missing values as well, 3, and on longitude 8 was missing, we got that value at 3. That will be a 8.5 something. You can do interpolation, and you can do interpolation like this. Let's say that you have a longitude but you don't have latitude. You have longitude, you don't have latitude. So again, interp lat, it will, what we do, it will interpolate the latitude. We have longitudes, we have latitudes, and this is longitude, and I want to find out at 45 what will be a latitude. So this is the latitude. So if you have missing data, same vice versa you can do interp lol for to extract the longitude data of it. Now raster data analysis, how to convert a georeference. If you don't have let's say you have just images and you have to convert that images as a georeference data. First of all, you require a latitude limit, then longitude limit you require, and the what will be a raster size you require. When you have this raster size, latitude limit and longitude limit, we use georeferences. Okay, and from where column will start, from the north side. Okay, so these options you can give it, and when you run this, a georeference is created. Latitude limit, longitude limit, what is the raster size, and all these things, and you can plot that image within this references, or any matrix which you have, you can plot it with this reference. One more example of raster analysis, if you have to find out the coordinate of pixels in images. Let's say I have this data which I am using, that is a aerosol data. First of all, to read the TIF file, we use GeoTIF read. We will get the matrix and we will get the reference of it. Then to extract the pixel centers from this data, we use pixel centers. We will get the x coordinate and y coordinate of every pixels. And further what we are doing, we are going to do a surface plot of it. Surface of x, this A matrix with respect to x and y. So what is the benefit of using this? Let's say I have some georeference data and I want to know that at which place the value is maximum or minimum. What is the value basically based on the color? And further how we are going to view these, and the material and shading kind of things, I provided it here. So my graph will come like this. Now let me undock this graph first of all. Okay, so you see, if I rotate this graph like this is the whole map as a surface. What we did, we had images, we extracted the pixel centers, and we had a matrix. We did the surface plot. You can see that where values are high and where values are low based on the color. If I click on this color bar, a color bar will be appeared here, and the blue which you see, their values are low, and if you go up, then values are high. And further, not only this, if you want to find out what is the value at some places, just click on this, and this is the x value, y value, and what is the z value on this. So this is the benefit of using, or you can rotate it like this also, and you can see where values are very high. This is the aerosol data which I plotted it here. Fine. Now conversion between vector to raster data. This is also very important. Let's say you have vector data, you want to convert in a raster data. So we use vec to matrix. if I give this command vec to matrix, what it will do, any vector which we have, vector data, it will be converted in a raster data. So in this case again we are loading that cost line data, means the ages of all whole world. Okay, so vec to max, cost line data, lat data and long data, and this is a latitude limit and this is the longitude limit, and it will filled, so it will look like as a polygon. And further, so this is the first we converted this ages as a raster data. Now we are reading the shape. This is again vector data. This is a reverse which we are going to relocate it. Again we are converting this river vector data lat long value again as a raster data. Now further to plot this geo show, and what kind of color map do you want, that also define it, and you will get the plot of the same. So this is the plot. Here we didn't use any kind of projection, so it took as a default. So this blue line which you see, that is the river flowing. The blue line which you see, that is the river. Okay. And the green is that a land area. And the blue, this blue which you see, that is the sea. Now how to combine the raster data and vector data? It is very simple. Just plot the raster data and then plot the vector data. It is very simple. Plot raster data, then vector data, or first plot the vector data, then raster data. So same, I am going to plot the loading the again ages of whole world, and I am going to load that topo data. Topo data is again, that is a raster data, and I am creating a georeference here. And just before doing this, let me clear all output first of all. Okay, now we created a reference data. Here we are using the projection Robinson, then geo show, latitude, geo show. This is the matrix of raster data, and this is a reference of raster data. Display type, that is a texture map kind of things it will looks like. So if I run this, so it will look like this. And then the last, that is a vector data which we are plotting it here. Geo show, this is the ages only which we have. So this is the ages of whole world map which is showing you like this on the same map. Next, terrain and elevation data analysis, which was in our agenda as well. So one example I am going to show you on this one. So what we are going to do, we are going to calculate the gradient, slope and aspect value and elevation data. You will have your raster data. Based on that we are going to calculate this. So just I created one georeference, that's all. And here this is the reference, and here we are creating the matrix. So you may have your our raster data. I am just creating the customizing it to get the all information like aspect, slope and gradient in north side and gradient in east side. Just we use gradient m, and this f is your this matrix, and r is the reference in this case. Fine. So we got the gradient, and let me plot that first of all, that raster data, how it looks like. Instead of this you may have your own map as well. आप map भी use कर सकते हैं. So I am using just, this is my raster plot which I have in a coordinate. Okay. So in this map I have to find out the gradient and all this kind of things. First we are plotting the gradient. Already we got, we are plotting this geo show gradient and north side. In the north side, using the reference this. So this will show you the gradient in the north side. This is the gradient in the north side. Further, if you want to plot the slope of it, so slope already we extracted. So this is the slope. This is the slope it is showing you. Based on the color, it is also showing where slope is higher, where your slope is lower as well. I use this customized thing to visualize based on the colors. It will be more visible. That's why I use this. So like this, you can do analysis on this kind of data. You have to find something from there. Now about geometric geodesy data. What we can do in geodesy first of all. So in this, these are the things, key features which we can do. Modeling the 3D coordinate and vector transformations, great circles, geodesics and rhomb lines plotting, length and conversion between length and angles, small circles and ellipses. Let me discuss one by one all. So first of all, modeling the earth. We can represent the shape and size of the earth, or if you have to, instead of this, if you have to model the moon, that also we can do it. Depends on us. Using 3D coordinate and vector transformations means if you have to do some kind of transformation from 3D to 2D or 3D to 2D, or you say from global reference to local systems. So this kind of transformations we can do in geodesy. Plus, if you have to find out the shortest spot between 2 points, that is the rhomb lines. That also we can do it. We can extract the this kind of things also. Or if you have to find some kind of curves, or if you have to find out the great circles, we can do this kind of analysis also here. Or if you have to do conversion, let's say that I have data as a kilometer and I have to convert in miles, then how we can do it, that kind of conversions. Or if I have data as a degree, if I have to convert as a radian. So it is not a Cartesian, whatever I am telling, that is based on the georeference. Or if you have to plot some circles or ellipse, that analysis also we can do. And further, if you have to find out the intersection points of polygons, or if you have to find out the parallels, or if you have to find out the some zones or leons. So we are let's see one example that how we can do it, and it will be more easy to understand. Okay, so let's here what I am going to do. I have a coastline data, means I have edges of data lat long, and I have to find out what is the area. Let's say I have to find out the area of India, or if I have to find out the area of any lat long values if I have. So first of all, here again, let me do one thing here, just clear everything, all variables, and just I am going to run this only. Okay, now I'm going here. So here what we have, this is the latitude. Okay, latitude is there, this is the latitude. To separate one zone, means one country with other country, we define here NAN. Okay, so if I have to find out how many countries are in this lat and long, some is missing, NAN will be as a missing data, is missing in cost lat. It will tell me how many surfaces are individually surfaces are there, or how many countries are there. 240 countries are there here, right? So total number of areas also we will get in this case 240. So we have cost line data. We use this function to find out the earth area, earth radius. Instead of earth, if you have to find out the moon radius, I will write here moon. Okay, now we use this function to find out the area of all objects, or all countries, or of all surfaces which are individually there. So if I run this, I will get the 240 areas. So let's say if you have to find out the area of Delhi or area of Uttar Pradesh, you require a coastal line of that and use this function to find out the area of that specific part. Now here I have this polygon. Okay, let me run this one. So it is still running. Just 1 minute. Let me close all this map first of all. Okay, I am going to run this, then I am going to do a map show of this both. You see, this is a two polygon. I have to find out what is the intersection point of this. What is the x1 x value and what is the y value. 2x value and 2y value we will get it. So for this we use poly x poly. So this we use for the georeference. If you are using Cartesian kind of local reference, then there is a different way to do it. Okay, so if I run this, what we will get, x value, two points are intersecting, so x1 x2 and y1 y2. So in a single line you can find out the where they are intersects. Now conversion from linear measurement to spherical measurement. So let's say that you have data in degree and you have to convert in a nautical miles to dig to nautical miles, and the values is degree is 1 degree. 1 degree is equal to 60.0405 nautical miles. Same thing I am going to do based on the moon radius. What will be a 1 degree in nautical miles on the moon? So it is showing you like this. This is the statue miles, degree to SM statue miles. It's shown. Now to generate circles, how to create circles on any map. So first of all we are going to define the projection, grid on, frame on, then set GCA, where is the origin of this, lat long. Okay, so if I run this I will get the first of all a globe, ortho globe. Okay, and this is the origin is there, so it looks like this. Now let's say I have to plot a 3 circles. These are lat long value of first circle, lat long value of second circle, lat long value of third circle. And what kind of circles we are going to plot it. One first circle will be a small circle, second circle is a loxodromic circle, and third circle is a great circle. So to do this, to plot a first kind of circle, as circle 1, this is the lat value, longitude value and the radius value. Okay, so same thing here, this is the range of this radius from 0 to 150, and third is this one. Okay, if I run this is the great circle, so this is the RH. Okay, I forgot to run this one. So if I run this, circle will be created, 3 circles will be created. So first this plot which you see, what we are doing it, we are just plotting the center of the circle. This plots all 3 circles, we are plotting it, and we are writing some text also. So to write the text we have to, we require a latitude value, longitude value, and what text we are going to write on it. So if I run this, we will get that all 3 circles. This is first one, this is second one, and this is the third one. This is the center of that third one circle. These are the text, how to write text on geographical map. Fine. Okay, this was about the geometric geodesy. That furthermore what you can do using this, let me show you first of all. You can already we discussed the great circles and a small circle, ellipse, Jones plots, and modeling of the earth. This all process you can do using mapping toolbox in MATLAB. Fine. Now the projections, already we discussed about projections, how to project it. The main 3 families I am going to show you, that what kind of projections are available in mapping toolbox in MATLAB. As we know that there are more than 65 projections available in MATLAB. This is a cylindrical projection. When you unwrap this, it will look like a rectangle. So wherever this kind of maps when you see, that is called cylindrical projections. Another can be a conic projections. When you unwrap this, it will look like this. That is the conic projections. And the third one is azimuth projection. So that is a spherical kind of things. When you unwrap, it will look like a circle. Further, if you want to see that how for projection you are going to use AXEM, AXESM, and okay, not this one, just wait a minute. Okay, these are the projections which available in MATLAB. Okay, this is a cylindrical projection. So if I want a Balth SRT projection, so I will write AXESM and the projection name. Cylindrical projections are there, like pseudo cylindrical is there, subdivided parts, conic projection is there, azimuth projection is there. So depends on you that what kind of projections do you want for your data, and you can do it based on that. Fine. So this was about the projections. Before projections, now about data representation. This is very important. How to represent the data in our map. So our objective is do a pre-processing on data. If I am missing data, then how to do a pre-processing on data. Then displaying the data on customized map depends on you that what latitude, longitude reference do you have. And the data which I have, that is a district data of India, okay, and the temperature data we have. Two data we have, district and temperature. What I have to do, let's say that I will click somewhere on the map and it will tell me that on that specific district what is the temperature and what is the district name. This we are going to do it. We are going to use the live script for this, and to display the data we are going to use the mapping toolbox using the GeoShow. Okay, this is the last of this session which I am going to show you. So let me clear everything, and I am going for that example. Okay, I have, first of all let me show you the Excel file which I have here. So in this Excel file, first column is district. Of every district places we have a latitude and longitude value, and we are going to visualize the minimum temperature on that. What is the minimum temperature? So here you see, in like if I am talking about Mandi, there is a missing data, right? So same there are multiple missing data, like in Sangrur there is a missing data. We have to interpolate to fill that missing data also. So this is the first step which we are going to do it. And I have the shape file of India. So first of all, just wait a minute. So first of all, yes sir.
There is a lag.
Okay, there is a lag. I am waiting, sir, right now. So right now, this file is open. I mean, this live script is visible. Not yet.
It is a visualization of geodata.
Actually, I think, sir, maybe because of a slow internet, there is lagging. Before this problem was not there. I don't know why it is lagging a lot. Right now, sir, this is visible. Okay, I am going to explain again, sir, what I am going to do it. This PPT is visible right now, this page. Data representation, this page is, sir, visible.
Which phase? It is data representation, yes.
Hi, okay. I am explaining again, sir, what I am going to do it. We have to represent the data on map. Before representing data in map, we are going to do some pre-processing on data. Then we are going to display that data on custom map like this. Second thing, the data which I have, that is district data, and another is temperature data. So in temperature data we have missing data also. We have to fill that missing data before plotting that. And solution is that we are going to use live script capability for pre-processing on raw data, and we are going to display that data on map. Sir, this live script is visible right now?
No.
No. Okay, I am waiting, sir, when it will be visible. Still, sir, this live script is not visible?
The slide only, PPT slides.
No, sir, already I am on live script.
Now it's coming.
Now it's coming. Okay, fine, sir. Okay, there is two way to display the data. First, I am showing you that how to display a basic data. We use geoplot for this. If you have latitude value, longitude value, just use the geoplot and all data will be plotted. And the data which will be plotted, how you want to represent on the map. So I want to represent as a circle, then 0 it will be as a circle. And the marker size means the circle you want big circle or a small circle. What I did here, I created a random circles here using rescale command. If I use the rescale command and if I give 120, 1 will be minimum value of circle and 20 will be a maximum value of circle width basically. So in a simple way we can say that if I have to do geoplot, if I have to plot lat long value, we require a latitude value, longitude value, and some properties you can define it like this. So what I am doing, I am loading this coastline latitude and longitude value, and whatever the length of this latitude and longitude is there, I am running the for loop for the same length. And one by one, all latitude and longitude values I am plotting it. Also I am writing the text also there. Text what I am writing? The values which I created in a matrix. So if I is equal to 1, first latitude longitude will be plotted, then text will be plotted on it. Then I is equal to 2, the next will be plotted, I is equal to 3, next will be plotted. So what I am doing here, I is equal to 1, it will start from 1, step size I am taking 100 and total loop it will run for the length of coast latitude or longitude. So if I run this, so it is still executing. So one thing more here in MATLAB there are offline plots. To install the offline plots you can go in add-ons of MATLAB and from there you can search different plots. This is the offline plot which I am using it. Sir, this graph is visible? This graph? That graph
No.
with... Okay, I think it is slow. Okay, now it is visible. So what I did, I used the geoplot x latitude value and longitude value. Latitude is on y-axis, longitude will be on x-axis. So latitude value, longitude value, and here I define the size of circles also in that geoplot. So the different size of circles is there and different plots are available there. This is the first way that how we can represent data on map. And quotes is this. Second thing, I was showing you this Excel file. Let me show it again. I think there is a lag. This is the issue here actually. So I am going to open this outside the MATLAB again. So this Excel file is visible here again? No?
No.
Okay. I am waiting, sir. I am waiting. Still sir not visible this Excel file?
No.
Okay. It is so much lagging.
Now we are getting the MATLAB script.
Actually, sir, right now I open the Excel file. Excel file means again.
Now we are getting
Excel is visible,
now
sir?
Excel file we are
Now it is visible. Okay. So in Excel file again, the next what I
Excel file loaded.
okay. Here I am going to plot the district and based on the district I have latitude, longitude value plus what is the temperature there. So here we have missing data, so we are going to do some pre-processings as well. So I am going to open the live script again. Sir, when live script is visible, then please let me know.
Some live script.
Live script is visible, na, sir? Okay. So what I am going to do, I am going to read that table using read table command. And this is my Excel file name. My data will be saved in a temp data as a table. Now what I am going to do, I want to going to identify if there are missing data or not in my temperature data which I have. So temp data dot this column name is missing. If I give this command is missing, it will tell me that how many missing values are there as a logical index. Wherever I will have missing value, I will get 1. If I don't have missing value, I will get 0. So and now if I do sum of it, it will tell me how many missing values are there. Okay. So further what we are going to do it, when we got that we have a missing value, then we are going to fill that missing value. So first of all I am going to run this to identify that how many missing values are there. Just I clicked on this blue strip and here I will get the result that how many. So total 21 missing values are there. It is showing me in the graph total 21 missing values are there. So we have to fill this missing value. Okay. To do this, how we are going to use the live script for this? I am going to insert, I am opening the task. So this task is visible.
Yes.
Okay, fine. So here we can use this kind of templates for data pre-processing, like clean missing data. If you have outliers, then remove outliers or fill outliers. Or if you have not smooth data, then how you are going to smooth data. You can smooth it as well. In my case, I am going to fill that missing data. Then I choose this template. So now a template will be open here. Okay, see here I don't have to write a single code. Now in input data I have to provide that what thing I am going to fill. So this is temperature data I am going to fill wherever I had missing data. And that is the minimum temperature. Okay, this is a table. In table that column I am using, that is mean underscore TMP. So you can see here in this figure, hope that this figure is visible, wherever that red line which you see, that were missing data and it is filled. It is visible, sir? This figure?
No.
Okay, okay.
No. No.
So the blue,
It is visible.
okay, fine, sir. So that red circles which you see, that were missing data and it is filled now. Further I am moving here. What kind of method are you going to use that fill missing data? So here is the option like constant value, previous value, next value, nearest value, linear interpolation, spline interpolation, or some different kind of other things which you can use it. So after doing this, just right click on this template and there is an option convert task to editable code. So when I click on this code will be editable. We can edit now this code. Output I am getting here as a clean data, and this data we will use to represent on map. So same thing I did it here, fill missing temperature data. I filled that. Next that next script file is visible. Just I switch the script file actually. Here it is written field missing temperature data, which I am using, field missing temperature data. I filled that missing data, and further I have to represent this temperature data on the map. So what I am going to do, I am extracting the latitude value from my table and longitude value here, latitude and longitude. So we have latitude and longitude, and we have temperature in data as well. Now to show this data on the map, so what we are going to do, I am using here world map as a India, and I will loading that cost line lat long value which is available. Geo show, if I give this command, that then that data will be plotted. After plotting this is very important, make a symbol spec. So this is visible, make a symbol spec here. I am using make a symbol spec to patch that different states. So different states will look in a different color. Make a symbol spec. So what I am doing to do, patch. Instead of patch, if I have to plot polygon, instead of patch I would write polygon. Or if I have to do a line plot, instead of patch I would write here line plot. So how this color will be patched? Patch means coloring of that area, fill the area with different color. So based on the index, the states which we had here in that shapefile, based on that a different color will be patched here. Then we are plotting that shapefile also here. If I run this, it will take a little time here to display that output. So what we did it, we had data in Excel file, we loaded that data in live script, then we used the pre-processing to fill that missing temperature data. Now we are creating a template of whole India map, and that data I had as a raster data in a shape file. So now it is plotting that whole India map right now. So actually this data is very big, so it will take a little time to plot the whole India map. And further, when this graph is plotted, what we are going to do, we are going to plot the latitude value and longitude value as well. So to plot the latitude and longitude value, we use the geo show command, and some text are also we are plotting it there. So it is still taking time. Okay, and here geo show, what I am using, latitude longitude value, display type as a point. So everywhere it will look like as a point, and marker is 0, that is circle, it will look like a circle. And what is the marker edge color, it is as a red. And what is the marker face color, that will be also as a red. And marker size means width of that circle, what will be a width of that circle, that is 3. Then further, we are we are writing a text. This is the x coordinate, this is y coordinate, district, and another text, click on red point to know the temperature data. Okay, so now we have this India map. This map is visible or not right now?
No, it is not visible.
Okay, it will be visible soon. No problem, I am recording this video as well. I will share the link, sir, to you. So now, sir, it is visible. All data here. No. Okay.
No.
Okay.
Now it is visible.
Okay. Can you see that dot red lines on map? No. Okay. This is which you see right now. There is no not a single data there. Further, I plotted longitude, latitude as a red circle. Yeah, that is a red circle. Now you see, if I display the temperature, all temperature data in this map, it will look very dense, and we will be not able to identify that what places are there and what temperatures are there available based on that places. So better one by one we can do that kind of thing. So further, what I am going to do it, I am running one infinity loop for while one. While one, if I give this command, it will run for the infinity loop. And there you see one command that is input m. When I give this command, a point will be generated wherever I move my cursor. So when I click my cursor on any image, I will get the latitude value and longitude value. When I click on this image on any cursor, after I got the latitude and longitude value when I click the cursor, then we are finding the distance, the latitude longitude value whatever I got it, finding the distance with all latitude longitude value on the same point where my cursor is there. It will find out the minimum distance, and based on the minimum distance it will display the temperature and it will display the district as well. So let me run this first of all. So if I don't click anything, then I gave the break command also, so this will come from the this loop outside. So this is visible right now, a different figure, and there is a one plus sign is looking, I mean horizontal and vertical line. A different figure window is opened, and with a black horizontal and vertical line. So in this case, if I click somewhere, let's say I am going to click on some red point, it will show me what is the district and what is the temperature there. So this is the place Aligarh and the temperature is showing 19. So like this we can show a live data as well.